So this is problem 43 of chapter 19 of Giancoli 6th edition. So what is given to us is the value of these capacitance, these three capacitance. They all equal, so let's write them here. In the book, all of these capacitance are equal and given by 16 microfarad. Okay, and the only other piece of information that we have is the charge on capacitor 2. So the Q2. The Q2 is 24 microcoulomb. That's it. With only this information, we are asked many different questions. So we want to know what is the charge on each one of these capacitors. Okay, Q1, Q2, and Q3. And we also want to know what is the potential difference, the voltage across each one of them. And also across the whole circuit, this V that shows up down here, which was not given to us. Okay, so that's all we want to find. Okay, how are we going to find that? So, well, Q2 we already have, so I'm going to fill it up here. It's 24 microcoulombs. Okay, with Q2 and with C2, both are given to us, we can find V2, right? We can find the potential difference across C2, because all we need to use is this equation, Q is equal to CV. And so this is the equation that we use when we are dealing with capacitors. Okay, so I go here, I put that this V2 is equal to Q2 divided by C2, and I'll be able to find this value. This value is 1.5 volts. Okay, so we are done with this part. And what else is easy to find out? Well, we know that the charge around capacitor, the charge on capacitor C2 has to be the same charge on capacitor C3. Now, once we found this equilibrium, once we have finished charging all these capacitors, the charge for the capacitors in series has to be the same. If they were not the same, we would still have charges in motion. Now, once we found the equilibrium, the charges have to be the same, otherwise they can start flowing from one capacitor to the other. Okay, so then from that we know that Q3 is also 24 microcoulombs. And from that we can use the same expression, Q3 divided by C3, to find out also that V3 has the same potential difference, 1.50 volts. Okay, now the sum of these two voltages that we have, let me put these two capacitors here. This is the capacitor C2 and C3. So we have here the voltage V2 and here the voltage V3. The sum of these two voltages in series has to be equal to the total one. Right? So I know that this V is equal to V2 plus V3. So we found the potential difference of the battery, which is 3 volts. Okay, now the other capacitor, the capacitor C1, is in parallel with these two, right? So let me put it here. We know that C1 is in parallel with these two. So the potential difference at the bottom here, the potential difference between the two capacitance here and the potential difference for C1 have to be the same. So from that we find out that this 3 is equal, is also the potential difference for the first capacitor. Now with that we are able to find its charge, right? Its charge, we just need to use C1, V1, and we find this this charge is equal to 48 microcoulombs. And this is the end of the problem.